10.4 is titled Using Pascal's Triangle. Pascal is a mathematician, and so he's credited with this. Pascal's triangle is an unending triangular array that was written about by Pascal in 1653. But evidence shows that it was studied much earlier in China and India, like 1100. As with many things in mathematics, the first person who's credited with it and who popularizes it is not the first person who studied it. Pascal's triangle has lots and lots of applications. We're only looking at the application to what we're studying right now. So understand that if you ever see this again, you might be like, well, that's not what I thought it was supposed to be used for. Well, that's okay. It has other applications too. Okay, so you're ready to take a look at it? I'm pretty sure I'm writing it right along with you. Oh, yes, I am. I thought that was true. All right, Pascal's triangle starts at the top with the single number 1. That's it. And then we're going to go opposite the 1 or out from the 1 in a diagonal fashion. It's going to look like a couple more 1s. I promise it's not all 1s. But the first 2 lines of it are. We're going to continue going out from it with 1s indefinitely. But what happens in the middle, between, right, this row I'm on is going to have 3 terms on it, is that I get the number 2. The next line, I'm going to go out numbers of 1s again. And I need to do the middle numbers between, and now there's 2 numbers I'm missing, and they're both 3s. We're going to do it again. We're going to go out in 1 more in each side. And you might be tempted to think, well, they should be all 4s now, and you'd be incorrect. But there are a couple of 4s. They're on the outer edges, and the one in the middle is a 6. We're going to go out one more time, and we're going to talk about patterns. Some of you are grinning. I think you've seen it before. Okay. The next 2 are still going to have 5s, right? The outer edges are always going to be the next number bigger, 5 and 5. And in between, I'm going to have 10s. So it's really important for us to understand how we create the next row. I've given you a number of rows so far, and we'd like to notice some patterns. So one pattern you hopefully notice is there's 1s on the outside, and that will continue forever. And if I go sort of 1 diagonal in, it's the number increasing, right? So you would expect my next one will start out 1, 6, and it will end 6, 1. And you would be exactly right. Every row and column will do that, or every row of the triangle will do that. But how do I get the 6 and the 10s? Go ahead, Elena.
Is it that,
Okay.
No, wait. No. Well, 3 plus 3 is 6, and 4 plus 6 is 10.
Okay.
Does that have anything to do with it?
Yeah, I've got some nods in the back too. Yeah, it's exactly what is happening. So the way that I get the 10 is I add the 2 above it together, and it makes the 10. So let's do the next column, or the next row, with that in mind. Like we mentioned, for sure it's going to start out 1, 6, and it's going to end 6, 1. But what's the number down here between the 5 and the 10 going to be? 15. And between the 10 and the 10? 20. And there's lots of symmetry in this, right? I'm going to have another 10 and 5 going to make 15. So there's always a repeating fashion within a given row as well. Okay? So let's see how far. Let's go 2 more down. I have to make mine a tiny bit tinier. So let's go down to the, where we get eighths showing up. So I've got 1, 7. What would be the next number? 21. And then 35. And I'd have another 35. And then they repeat going downward from what they were before. 21, 7, and 1. The next row will have a 1 and 8. What would I get next on here? 28. And then 56. And then 70. Yeah, 35 and 35, 70. And then it starts repeating again, right? I mean, from the other side, so I have 56. And then 28, 8, and 1. And this could go on indefinitely, right? And if you could write it all the way out until you get to 52s, don't advise that. You could use it for the problems that we were doing in the last section. Okay, so what's the application? What is the connection? Well, I'd like to show you a couple things on the edges of this. We're going to make a little bit of a label. I need a little bit more space for my label. We're going to look at the row itself. So the row that we are on, and we actually start the top of it by calling it row 0. So the row that just has the 1 on it on the top is considered the 0th row for what we're going to work with next. I'm going to call it row 0, okay? And then the next one we'll be calling row 1. And then the row with 2's on it is called row 2, and the row with 3's on it is called row 3. So the number that's listed second is the name of the row. Easy enough? That's how we decide. So this is 5, 6, 7, 8, and so on if we were to continue. There is one more interesting application that I'd like to take a look at with you that comes about with this one. If we were to add the rows together, like if I were to add everything on this row 8 together, I added 1, 8, 28, 56, 70, 56, 28, 8, and 1. Right, if I add them together across, so in other words, the sum of the rows, I want to show you an interesting pattern, again, that develops. So this first sum is 1. So the row 0's sum is 1. Row 1's sum is 2. Row 2's sum is 4. Row 3's sum is 8. And I have 16, 32, 64, 128, and 256. I'm just adding across. I don't need you to add it together, but I just want you to see something interesting. Do you see a pattern in these numbers? What pattern do you see? There's a couple of them, actually. They're multiples of. They're not multiples of. You're close. They double each time. That's true. They do double each time. That's one of the patterns. But they aren't multiples, Sydney, but they're powers of something. What are they powers of? 2. They're powers of 2. So on the first one, I'm going to change the color I've got over here to be able to write in this like pink color over here. This is 2 to the 0. And this is 2 to the 1. And this is 2 squared. And this is 2 cubed. And notice, 2 cubed is on row 3. Isn't that interesting? There's lots of really cool patterns in this triangle. But let me show you what we're going to use it for, and you're going to be very pleased about this, except you're not going to want to write it, but you're going to write it anyway. Okay? We're going to write this same triangle out, but instead of writing all the numbers that are showing up inside of this triangle, we're going to write the combination value that it stands for. So, flip over to your next paper. Oops, I need it. Are you kidding me? I have it on the same screen. Of course I do. Let's see. Let's try this. Okay, I got a blank screen. That'll work. The top, that little one that's all by himself in the very top, is 0C0. Very uninteresting. 0 items chosen 0 at a time. There's only one way that can happen because you're not choosing anything from anything. It's not very exciting, right? However, the next one is 1C0 and then 1C1. I have one item, I'm choosing none of them, or I have one item, I'm choosing one of them, right? If all that's available when you go over to the GC today is a piece of chicken, that's all there is. You can either choose it, there's one way, you choose it, or you don't choose it, there's one way, you don't choose it. These are both ones. The next row is 2C0, 2C1, and 2C2. There are 2 items, you choose either 0, 1, or 2 of them. And this pairs up perfectly with what we'd called row 2, and all the 2s are matching, right? We'll go a couple more rows down. We have 3C0, 3C1, 3C2, and 3C3. And it builds on itself like this. I'll write one more row, but I don't want us to think that we have to write this out in order to be able to do the problems. What we have to be able to do is to look at the other triangle and interpret what row I'm on and what entry I'm in. So, we're going to jump back over here. If I'm interested in finding, or I'm interested in identifying what value I'm at right here, the number 5 there. Well, I'm on the 5th row, so that's 5C something, right? 5C. And it's always C0 to get the first entry, and it's C1 to get the second entry, and so on. That location that I just put in the circle is 5C1. So why is it helpful? Well, because take a look. If I'm doing 6C3, I don't have to do a calculation. I can just find it in the triangle. The 6 tells me I'm on what? Row 6. And the 3 tells me it's the 3rd entry, and I'm going to say after 1. The first entry 1 is the 0th entry. So it's the 3rd number after the number 1. So if we go to the 6th row, what is the 3rd number that occurs after the number 1? 20. How cool is that? It's a very nice application when the numbers are small enough. This number is 20. How about 8C6? So I'm on row 8. 1, 2, 3, 4, 5, 6. It's this 28th. Okay, so now that you know this, could you utilize this back in section 10.3? Sure you could if the numbers are small enough and your table and/or is big enough to accommodate. I've literally had students write this table out to like row 25 before. More power to you. If that's what you want to do, go for it. You're going to spend a lot of time writing it out, but maybe it's worth it in the end. They felt like it was. So if we're taking a look at a few of these examples occur much like the ones back in 10.3. They're a descriptive phrase. We have to figure out what the C's, the value before and after the C are, but they are combinations. It says we've got a committee. The committee is actually what tells you it's the combination. And it's a committee of 3 people. So we're choosing 3 people. There are 7 women to pick from and 3 men. So those categories are important in order to look at the description. This says, it's kind of like saying the black cards or the diamonds or whatever. Those descriptions are what we're using. Exactly 3 women. How many women are there? 7. How many am I choosing? 3. But I'm not using factorials. 7C3 is in my table. What is 7C3? 35. And to be honest, we've already done this problem before, and we got 35 as well when we did it. So there are 35, selections, or I'll call it ways. How about 3 men? 3C3. You probably know what that is. If you don't, it's okay, but you can still do it from your table. What is 3C3?
1.
It's 1. It's the last entry. It's 1. How about exactly 1 woman? What does that mean? 2 men, 1 woman, right? I got to have still 3 people. So I still have to have a total of 3 people. So I've got 7 women, and I'm going to choose only 1 of them. But in order to complete the committee of 3 from the 3 men, I also have to choose 2. But each of those numbers is in my triangle. So flip back. What is 7C1? I won't flip back. You can.
7.
It's 7. And what is 3C2? It's 3. 7 times 3 is 21. Last problem, finishing perfectly. We want to do exactly 1 man, which means we need what? 3C1 and then 7C2. And you might think, well, it should be about the same. And the answer is it's close, but it's not exactly the same. 3C1 from your table is 3. What's 7C2? $21. Yeah, it's a 21 in your table. So 3 times 21 actually gives you 63. And the reason that it's bigger is because there's more women to pick from than there were men. That's why it didn't end up giving us a symmetric value. All right. We'll convene again on Thursday.